we had done like the factual information about in-center, right? We had done this part. We had said that the in-center is where the angle bisectors are congruent. We had said that it was the center of the triangle where there was also a center of a circle that could be inscribed in the triangle. We said that the sides of the triangle were equal distance from the in-center, and that that was always drawn where the segments, they always had 90-degree angles drawn, and that's not part of those lines where it makes the angle bisectors, that would be different lines potentially. Like in this picture, the lines aren't actually drawn. You can see, right, like this is part of the angle bisector, but this angle bisector is not a radius of the circle. That angle bisector doesn't have a radius of the circle. There's a right triangle version. The in-center is always inside the triangle. Okay, so what we didn't get to was the mathy part. We didn't get to do examples of those. So we're taking our notes. We had gotten to this part of circumcenter, and now we need to do the in-center problems. So in your assignment, you've probably done a lot of the questions, but you skipped the in-center questions. And then you might have just had some questions that maybe gave you some trouble, possibly. Yeah, okay. So let's look at example 5. Example 5 says, in the diagram below, we have an isosceles triangle. What do you guys remember about isosceles triangles? Two of the sides are the same. They said that AB is the same as CB. So this side is the same as that side. And the angle bisectors are AD, BF, and CE. So they're telling you that you do have angle bisectors, which means that this angle is the same as this angle. This angle is the same as this angle. And this angle is the same as this angle. That the angle bisectors are drawn and they intersect at point X. BAC. Let's see where BAC is. BAC. From B to A to C. All of angle BAC is 50 degrees. So this is 50 degrees. Okay, if that whole thing is 50 degrees, what are each of the two angles? 25 and 25. Okay. Now, this is an isosceles triangle. So, and we knew, I'm going to do another color. We knew that this side and this side over here, we knew that those two sides were exactly the same. So if this angle over here is 50, what is this angle over here? That's 50 as well. So if this angle's 50, then what are these two pieces? 25 and 25. Okay? And if this is 50 and this is 50, what's this up here? 80. And then what are these two little pieces? 40 and 40. Okay. All right, let's see what the question is actually asking for. They said find the measure of AXC. So from A to X to C, A to X to C, that's this angle right there. A to X to C. How could we find the measure of angle AXC? That's 25, that's 25. Oh yeah. You could say that this right here, we can't necessarily assume it probably is a right angle. You are probably right, but we can't assume that. There's another way to get it though, without dividing these into two different triangles.
25 and 25 is 50. 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 25 and
we have the two 25s, and this whole thing should be 180 because this whole thing is one triangle. So we can do 180 minus 25 minus 25. What does that give us? 130. So the measure of angle AXC is 130. Okay. This next one says point T is the in-center of triangle PQR. Here there's no angle measurements given, so if they ever don't give me an angle measurement, I always go straight to drawing that inscribed circle. So that's what I'm going to do here. And you can see that they drew from here to the edge of the inscribed circle, from the center to the edge of the inscribed circle. They said this is a length of 15, and they did it with 90-degree angles. So whenever they do that, you can tell that they are showing you this is the shortest distance from the center to the edge of the circle. They are counting that as a distance. And if we go back to our notes, we know from this that whenever they do that, they are showing us what the radius is whenever they draw that 90 degree. Does that make sense? Specifically when they draw the 90 degree. Now we know if they don't draw the 90 degree, it's not necessarily the distance. We can tell that just from these pictures over here, right? From here to here, that is not the radius of the circle. Everyone see that? Okay, so maybe let's add some more pictures in. If I want to know the radius of this one, they would have had to have drawn it. It's going to have to be from the center of the circle. It's going to have to go perpendicular to the side. So it has to be perpendicular to the side. You can see where the side touches in one spot. You can see where the side touches in one spot. I can see over there where the side touches in one spot. It has to be perpendicular. That's where we get the radius. Over here, the side touches in one spot. The side touches in one spot. The side touches in one spot. That's where it has to hit to be the radius of the circle. Everyone see that? So radius, radius, radius. Okay? So for these pictures, it could be on the line that's the angle bisector, but it doesn't have to be. Could be, but it doesn't have to be. The way that they show you that it is they draw that little 90-degree angle to show you that it is on that line. So for this particular example that we are looking at, example 6, they're telling you it's an in-center, and for these angle bisectors, they're also drawing that 90-degree angle. They're telling you, yeah, this is from the center to the edge of the circle. This is a radius of the circle. Okay, they're making that clear. So if this radius is 15, what do we know about the other ones? They're also going to be 15. So this one is 15, this one is 15, okay? All right, so ST is what? 15. If TU is 2x minus 1, what am I going to do? I'm going to say 2x minus 1 equals 15. And then I can just add 1. 2x equals 16. And then I can divide by 2. X equals 8. Okay. This one says angle PRT. So P to R to T. So from P to R to T. PRT is this angle right there. If PRT is 24 degrees, then QRT is what? If PRT is 24, then Q to R to T is also 24, because QRT is this angle. QRT would also be 24. Okay? The next one says RPQ. So from R to P to Q. R to P to Q. RPQ is this. So RPQ is 62. If RPQ is 62, then RPT. RPT. What would RPT be? RPQ is the whole thing. Everyone see that? RPT would be, say it again, 31. RPT is half. RPT is the middle part. RPT is just this, 31. All right. What are some problems from 14 to 45 that we have run into where we are like, nah, I don't know. I'm very confused. (14 through 45). Any questions we have found that we are confused on? Any of them we've had a hard time with? 14 to 45? How'd you guys do on 18 through 29? The pictures? How did we do on 18 through 29? They drew, do you guys see how they drew some of the trivia stuff? They drew pictures of the trivia. So what is this a picture of? So we see, what did they draw? They drew angle bisectors, right? Which one is that? In-center. So the triangle point of concurrency that they would have shown is an in-center, because they drew angle bisectors. Okay? All right, here they cut the sides in half. We know that a couple of them do that. They cut the sides in half, but they didn't do it with a line that's perpendicular. So they cut the sides in half, but they didn't do it with a line that's perpendicular. So which one does that? Centroid, right? Centroid has medians. Medians cut the sides in half, but they don't do it with perpendicular lines. You guys see that? That's one of the facts. Okay, so this is centroid. Okay. This one over here, we've got, it goes to the top, it's perpendicular to the bottom. It does not cut the sides in half. It's just perpendicular. Does the in-center say that it's perpendicular to the bottom? Has to be. It could be, right? The in-center could be, but it doesn't have to be. Orthocenter. Orthocenter is perpendicular to the bottom, but it doesn't cut them in half. So this is orthocenter. Okay? Now this one, we've got something happening here. And what they did is they didn't draw the whole line, so the line could go further than this, right? It would just make for a messier picture. Okay, so they have the lines here, they're perpendicular to the sides, and they cut the sides in half. So if you're perpendicular to the sides and you cut the sides in half, what do you call that? But what do you call that line that's a perpendicular and it cuts the sides in half? Perpendicular bisector. Which one has a perpendicular bisector? Circumcenter. Yeah, circumcenter is the perpendicular bisectors. Okay, now this one is kind of, Emmanuel, what you were thinking when you saw number 20. So we can see the right angles, right? What do these little lines mean? They're equal. So they are saying that you have these 90-degree angles, but specifically they're telling you these little lines are equal in length. So this is where we're picturing, oh, we've got a circle on the inside. You have distances that are equal in length. So what is this one? This one's in center. You have a dot on the inside that is an equal distance to each side of the triangle. Okay, what about this one? You have a dot on the inside that has an equal distance to each vertex. Not centroid. Circumcenter. So this is the one that had the circle on the outside, where from the center to the vertex was the radius. From the center to the vertex, from the center to the vertex. So this is circumcenter. Okay, what are they showing us pictures of on this one? What are these lines called? Altitudes. They have 90-degree angles, right? But they don't cut the sides in half. What has a 90-degree angle but doesn't cut the sides in half? What is it? It's the orthocenter. These are altitudes. This is the orthocenter.
How do we know their altitude?
You know their altitudes because the only other option would be perpendicular bisectors, and they did not cut it in half. Or I guess they could have been this, but they weren't showing you that these were equal in length from the center, like this one did. Mm-hmm. What's 25 showing you? What is 25 specifically showing you? Yeah, you're seeing what's being bisected. The angles. And which one has bisected angles? In center has bisected angles. Okay? All right, this one over here, we've got a 90-degree angle and the sides are cut in half. A 90-degree angle and the sides are cut in half. Not orthocenter. Circumcenter. Orthocenter has the 90-degree angle, but it doesn't have the sides cut in half, right? So this is circumcenter. Circumcenter. What about 27? Yeah, 27 and 26 are the same picture. It's just on a different shape of triangle. It's the exact same picture, two different shapes. So this is circumcenter. Which one has a circle inside? In center. Inscribed circle, in center. All right, which one has a circle outside? Circumcenter. Circumscribed circle, circumcenter. Circumscribed, circumcenter. Okay? These ones are just your math, your facts, right? These are your trivia facts. They're going to force you to look in your packet repeatedly to figure out what's where. So those you guys can find pretty easily. So I think I'm going to give you guys some more time to finish this now that we've done in center. How many more minutes do you guys think you need to keep looking over this? How close are we to being done? 10 minutes? 15 minutes? Okay. Let's go ahead and work on this, and then when you're done, you can go ahead and get it turned in.